Matt.
Oh, hey there. What are you doing here inside my luxurious loft?
Matt, we're doing day in life.
Oh, that's right. All right, give me a second. About to head to stroll through LG Yama's automobile, BMW, pretty sweet car. About to head through Winchester. Again, it's a BMW. Pretty good fuel efficiency. 18 mpgs on the
60.
16. Dude, you need to get a new car. Is that on the freeway or the highway or the roads?
I think that's highway.
Highway. I drive a Ford Escape. Get 33 mpgs on the highway.
It's also a mom car.
Pretty fuel efficient car. I mean, it's a mom car, but I care about the environment. So, what's more important, is saving the planet for our kids or driving a mom car? But it's pretty dope. We're heading to LG, play some football. Right now we're heading on Winchester, so because of a lot of ops on the road, we're going about 15 meters per second. Knowing that speed equals distance over time, 15 meters per second equals D over, just traveled about 10 seconds. So that gives us about 150 meters is what we traveled, using the math in the brain right there. But pretty chill. We out here on the field of Los Gatos High, also known as Helm Field. Our rich history here. We're going to show you guys a little bit about tackling.
You know, and football tackles are a lot like inelastic equations. You have two objects colliding together, and they stick together and do not come apart. And in football, you don't want to lose your man. All right. So in a football tackle, you get that strike step, and then you wrap up around the hips, and you crowbar.
You tell me, cash rules everything around me. Say dollar, dollar bill, yeah, dollar, dollar bill, yeah, dollar, dollar bill, yeah, dollar, dollar bill, yeah. Around me, say dollar, dollar bill, yeah, dollar, dollar bill, yeah, dollar, dollar bill, yeah, dollar, dollar bill, yeah.
Back here at my house, practicing on some dunks. Pretty typical thing we do over the summer. Was gonna get a D1 for dunking, but shoulder surgery prevented it. So anyway, physics. There's a lot of physics behind dunking, and that's projectile motion. And what's happening is when you're dunking, you're pushing off the force of the ground to get you hang time, and that is, when you're suspended in the air. And what's happening is horizontally, when you're in the air, you have a constant velocity. And the reason behind that is because the force of gravity is not affected by that. It doesn't affect your horizontal velocity. However, on the vertical side, on the vertical component, when you're jumping, your velocity always changes because the force of gravity is affecting it. So I'll show you a pretty cool dunk right here. Dude, yeah, come on, dude. You're so bad at dunking, dude. My 4'11" sister can dunk better than you. Come on, dude. Oh my god, dude. Like, seriously. Can you just actually start dunking?
You know what, Matt? My hand.
MRI. I have soft tissue damage.
Dude, why does my hand hurt so much?
Dude, it's because of Newton's third law.
What?
Newton's third law. For every force, there's an equal and opposite force.
Matt, out here at the hill, do a skateboard race.
Pretty typical thing we do over the summer.
Yeah, we're gonna try to figure out our velocity using some physics. So we got our GPE right now, because we're at an elevation, is equal to our kinetic energy, our KE, when we go down the hill. So you want to take 9.8 and multiply that by the height of the hill. We're gonna say about 20 meters, and then that's equal to our kinetic energy, which is 1/2 velocity squared. What was he saying? So, you ready, man?
I'm ready. You ready? Tell me when to go.
Go.
You ready to race?
Yeah. Woo! Oh my.
I totally beat you on that race. Dinner's on you.
All right.
All right, let's go. Dude, what's going on with your car right now? Just run out again.
All right. So Matt's gonna get out and try to push the car.
We got 4 forces that we got to deal with here in this pushing of the car action.
We got the force of the ground pushing up on the car. We got the force of the earth pulling down. Those equal out to 0. And then we got Matt's force of Matt's push that will be greater than the force of friction, and the car will move forward.
All right, let's see if I can do this.
Matt, jump in, Matt.
Dude, that was dope.